All right, welcome everyone. Welcome to this to the final lecture of this semester's A. Richard Newton Distinguished Innovator Lecture Series. And I think first, maybe an obvious administrative announcement, but you've each got or should have a course evaluation form. Fill it out during, at some point between now and the end of the class. We'll basically at 6, if you need a few minutes, there'll probably be a little bit of time, but hand that back to us. I think there'll be a box that's going to go around, and you can deposit it into that. We'll collect it basically. All right. So it's now for I guess the main event here. It's my pleasure to welcome Carl Bass. Carl is today. Or since May of 2006, he's the president and CEO of Autodesk Incorporated. Now, the company is a leader in 3D design and entertainment. It's on the Fast Company list of the 50 most innovative firms. He's held many positions with the firm, including Chief Operating Officer and CTO. And, the talk is really in keeping with a theme that we've had this semester, which is to understand what's happening in new industry spaces, as we did with electric vehicles, as we've been doing with digital media. So in this works out to be a perfect talk in that recently Carl wrote an opinion piece for Wired magazine entitled An Insider's View to the Myths and Truths of 3D Printing. And it gives you some insight also into what he's going to be talking about. He's on the board of a number of firms, Autodesk, Easy Open, and the Art Center College of Design. He's also on the advisory board, boards at Cornell and the School of Information here at Berkeley. So with this, it's my pleasure to welcome Carl Bass to today's lecture.
Thank you. Thanks, everybody. That's loud enough. Good evening. So what I was going to do is, when we were talking about what I would talk about, everybody's fascinated with 3D printing. I'm happy to talk about 3D printing. I'll talk a little bit about 3D printing, but it was also, interest in entrepreneurship and career advice. And so I was putting this talk together, and I thought, this is terrible career advice, asking people to do the impossible. And you'll see what I mean by doing the impossible. But what I was going to do is just give you a little bit of background about me and how I came to do what I'm doing, talk a little bit what I see as the important trends going on out in the world, including 3D printing, and then give you a couple examples of companies that I've seen recently that I think are really interesting and kind of capture the spirit of what's interesting in terms of innovation and entrepreneurship and really what's possible. So with that, let me just start. So I like you, I thought I'd go to college. I lasted 2 semesters. And I got to, after 2 semesters at school, I decided I got caught by the bug of making stuff. And I got really fascinated with this idea. I grew up in New York City. I grew up in an apartment building, had hardly made anything in my life. And all of a sudden, I got hooked with this bug of designing and engineering and making stuff. And so after 2 semesters of college, I left. And I went off and I started making things. I made things out of wood. I started making, so that's wood and concrete I made things out of. This is a boat I designed and made out of wood. There's some other boats. I built some boats on the coast of Maine. This was a great program where during the winter we would build boats, and in the summer we would have like an outward bound program from kids from the city would come up there and spend a couple of weeks sailing on these boats. And for kids from the city who you thought grew up in a tough urban environment, the scariest thing you ever asked them to do is solo on that boat and go to that island over there and spend the night by yourself. It's way scarier than anything they had seen in the city. And so I did that for a couple summers. This was one of the other boats, by the way, that is me. That's one of the earliest boats I designed. That was what, last year? Last year, a year and a half ago. It was made out of Army surplus pontoon tubes and 2x4s. And so this was a great example, actually, I thought, of design. These were you could buy these Army surplus tubes. What they were used, I think, primarily during like World War II and the Korean War. And the Army would pull up to a river with the whole infantry, had to get across. They would blow up the pontoons, they'd lay them in, they'd lay boards on top of it, they'd drive across and then pick up the bridge behind them and drive off. So we found these things, they were available for like 20 bucks a piece. And so we took a couple of them, lashed them together. We did about 10 of these different designs. By the end, they were very fancy and welded frames and stuff. But this is one of the first times going down a really, really large rapid, in which I didn't actually stay in the boat. That's the best view of it that they possibly could have gotten, because I swam pretty much the rest of that rapid. I also, here's a bench I made out of granite. So that's carved out of one piece of stone. It's a really dumb idea. Don't do it. Don't do this trick at home. It takes forever to carve granite of that size. Here's some stuff I've cast out of bronze. Here's a table I'm making these days. So I have a shop down in Berkeley and with a big 5-axis CNC router. And so I've gotten smarter than carving stone by hand, and I'm using my router to carve these things. And this is actually my favorite thing. So this summer, I have a 15-year-old son. So he and I have been building an electric go-kart. And so that's we bent and welded the frame, and we got a rebuilt motor that's 19 horsepower. So for all the engineering students out there, you can calculate what this thing's going to do on a go-kart that weighs about 300 pounds. This is me this is Autodesk. We just built a big digital fabrication facility in the city that's filled with digital fabrication tools, water jets, CNCs, 3D printers, and that's me standing in front of one of the CNC machines. There's one of the parts I just made. Here's a set of speakers I just did. I've been doing a lot of printing of 3D printing of speakers. So a whole collection of stuff that I've made, and that probably spans 30 years of making stuff and just a smattering. And so after about 5 years, 6 years, maybe 7 years of making stuff, I did actually return to college. I graduated, I got a degree in math, and right after college I came out and we started a company, a software company called Flying Moose Systems and Graphics. And so our product was called Hoops, and there was somebody's first attempts at a logo or a t-shirt or something that I was able to drag out of the archives. And so what we did is we started doing software for computer graphics. And we ran this company for maybe 7 or 8 years. Mostly we sold it to people who were doing scientific visualization, people who were doing CAD and CAM. And after about 8 years, we actually sold the company to Autodesk. And so that's how I got to Autodesk. I sold the company. I worked at Autodesk for a handful of years. I then left Autodesk, started another company, and then we sold that company to Autodesk. And then I just gave up. I just decided this is too hard to do anything else. And so I was at Autodesk. Some of you probably know what Autodesk does, some of you may not. But basically what we do is we build software tools. And so going from making stuff to nowadays, most of my professional stuff is we build tools for people who make stuff. And the people who make stuff are really in 3 different industries. The first industry we serve are people who do the built environment. And so this is a picture of Shanghai. There's an example. A huge proportion of those buildings were designed with our software. And so it's engineers, it's architects, it's civil engineers, and so it's bridges, tunnels, roads, dams, canals, and buildings are all designed using our software. And so that's one big industry we serve. The other is the world of manufactured products. Most of the cars in the world are designed using our software. I've just had a couple of great tours. I was at the Aston Martin factory, I was at the Audi factory, and then I was at a factory in Japan at Toyota. So it's kind of fun. One of the things that's fun about my job, because in some way I get to work with some of the most interesting and creative people. But as many of you know, the people who build these things are incredibly passionate about what they do. And so they love showing off. And so, for example, when I was in Germany, this guy that we've been working with on design came to me and said he'd always wanted to show me an Audi. And so I was at my hotel in Munich, and we're going to go to Ingolstadt, which is about 2 hours away. And he shows up in the office, and we go outside, and there's an Audi parked there. And it's a car, it looks like a station wagon. And I'm like, this seems very unimpressive to fly halfway around the world to get in a station wagon. Turns out it's called an RS6. And for anyone who's a car nut out there, an RS6 is a family car that has 588 horsepower. And we were in Ingolstadt in about an hour and 10 minutes. It was unbelievable. It comes out of, in the German market, people don't have multiple cars. But it's kind of like you drop your kids at school and then you go 200 miles an hour on the Autobahn. One class of customers are all building manufactured products, consumer products, industrial machinery, stuff like that. And then the third one, which is actually interesting, and many people don't know that we do, is we build software for people who make video games and films. So almost any film with visual effects is done using our software, things like Avatar, Life of Pi, almost anything you can do, almost anyone you can mention. I know every year at the Academy Awards, there are 5 nominees for Best Film for Visual Effects. And for the last 17 years, all 5 nominees have used our software. So we win every year, regardless of who actually wins. It's kind of stacked. So that, you know, and so it's really fun because in some ways, even though these industries are really different, I see this incredible similarity in what our customers are doing. They're taking these ideas that are in their head and they're taking it from there and they're getting a physical manifestation. They go from an idea, a concept, a thought, a feeling they're trying to create to a physical artifact. And the process, while the words are different and how they think about it are different, really, in many ways, it's a very similar process of going from ideation to realization of an idea. So what I wanted to do is take some time. I was going to talk about 5 things that I see going on in the world as a result of working with all these customers, and what I think are important trends for anyone who's going out into the world, is going to start a business, is going to join the workforce, is thinking about ways in which they can change the world. So here's the first trend, and I think this is an interesting one. It's about this idea of going from ownership to access. And what I think has become important, and you guys are the living manifestation of it, is people are now interested in access and experience rather than ownership. And you don't have to look any further than, 10 years ago there would have been a Borders and a Barnes & Noble, and they would have sold books and music and DVDs. For most of you, you probably don't own that stuff anymore. My kids laugh when I have a shelf full of CDs. They walk in and say, what is that thing? It's like, why don't you get out the 8-track tapes, Dad, while you're at it? Those things are artifacts because what people are really interested in is actually having access to it and being able to utilize something. It's much less about the ownership of it. And, a Zipcar is a good example. Pandora is an example. Dozens of examples. And I think this is really important in terms of building products that for what people want. Is it used to be presumed that as a sign of prosperity, a sign of wealth, rite of passage, people would own certain things. Nowadays, less and less do people want to own and maintain things like that. Here's the second trend that I see, which is this idea of using the crowd. And business has changed in many dramatic ways. The first thing is, for those who are interested in entrepreneurship, it used to be that raising capital was hard. Turns out that raising capital these days is not very hard at all. I mean, there's lots of sources. So going back to the 3D printing one, I went up the other day and I looked at Kickstarter. There are 75 projects on Kickstarter that have been funded to build 3D printers. I mean, compared to what you used to take to go out and raise money, you have the ability, first of all, to do things like Kickstarter. You have things like AngelList, in which individual investors contribute. And I think we've tapped into something really interesting as a different way to access capital. And for someone who, like me, who has supported many things on Kickstarter, I think it's interesting in that it's changed. Many of the things that I support on Kickstarter is not really because I want to own that thing. What I think is interesting, I want that thing to exist in the world. And it's as close to giving as it is to buying. I see something that I think is a great idea and I want it to exist in the world, and I'm willing to contribute to that project. And enough people are able to do that. Now, the second thing that comes with that, nobody has ever had such instantaneous access to markets and the response from potential buyers. I think that's incredibly powerful. We used to have to go develop products kind of in the dark and then show up and say, does anyone want to buy this? You know immediately you have a built-in audience when you do that. The other thing that I see going on is this incredible reaching out. It's kind of reaching outside the conventional places to look for new ideas. And so, there are companies now, there are car companies, large industrial companies who are looking out and finding small companies to partner with new ideas. It made big news last year when DARPA went and started crowdsourcing vehicles, saying that we can't innovate fast enough. GE is doing the same thing. I don't know if you guys have seen a company called Quirky. It's crowdsourced product design. So there's this new way of tapping into the crowd and utilizing all of us and finding people with the same special interest and the same affinities to be able to build a business in a way I don't think you were able to build one before. The third thing I think that's changed is this whole idea of digital fabrication. Now, the first thing about digital fabrication, look, the additive stuff, 3D printing, it's the thing that captures people. People are excited about it. And there is a little bit of science fiction about it. Like I said, I wrote a piece on this in Wired.com this summer, just talking about what I think is really the hype here and what's real. But there's no doubt there is an undercurrent of something that's real and important in this new way of manufacturing. And I think 3D printing is already changing stuff. And as we get faster builds and bigger envelopes and new materials, it's beginning to become more and more important. Now, the thing that I would say is more important to me is that I see additive manufacturing as part of a bigger set of things. What we finally have done is taken the microprocessor and applied it to manufacturing. And all of the things that you see up there, or at least the first three, all involve using microprocessors to control something. And what's so important, I think, about using a computer to control a manufacturing technique is what we've been able to do is kind of upend some of the basic tenets of the Industrial Revolution, which were that in order to make something of high quality at low cost, you had to make millions of them. What we're now able to do is make things in rather small lots at really high quality and repeatably good quality for a reasonable amount of money. And that's changing the kinds of companies we can create, the kind of products that we can bring to market. And I think that's really important. And those are the first three that I think are important. Now, the other one that I think is an emerging thing is what's going on in the nanoscale and bio in terms of self-assembling and emergent behavior that comes from things that put themselves together. Many of you have seen 3D printing of organs. If you haven't, there's a great TED Talk on the printing of a human bladder and a kidney. And the idea that you can print human cells or animal cells in general and make a functioning biological part, I think is incredible. So I think this idea of what's going on in digital fabrication is really important as people think about entering the workforce. Fourth one here is all about information. You guys are lucky as could be. You have access to information in ways that you can't imagine. When we were growing up, we had to go to the public library, look at the card catalog, and hopefully you would find a book that was written in the last 20 years on a subject you cared about. Nowadays, you can Google something and often be talking to an expert within 20 minutes. Certainly reading what the expert wrote, talking to an expert, and finding out information in ways that were not possible before. And if you grow up with it, you don't appreciate it. We used to sit, card catalog, wait for journals to be published. You could be 10 miles away from someone doing something identical, and you would never know that that person existed. This has completely changed. Now, the last one is what I call infinite computing. And basically, for many, many years, we've thought about computing as being kind of scarce and precious, that we don't utilize it. But as everyone knows Moore's Law, and you talk about how the price of computing is going down and the power is going up, and we're all walking around with supercomputers in our pockets, what's really going on is we are approaching a place where, at least in the limit, access to computing is almost free, and we have as much computing as you want. And if you look at any asset that we have to deploy against any problem, there are not many assets that are going down in price. There are not many things you can do that are cheaper than using a computer. Yet I still think we have a mindset that says this is scarce and precious and we should preserve it. And I challenge everyone to say, what would you do differently? How would you design something differently? How would you build a business differently if you assumed that computing was infinite? That if you look at things like the cloud, where I can build a scalable computer, I have access to as many cores as I want, and I can get it for fractions of a dollar per hour per CPU core. What would you do differently if you had access to all that computing power? Now, one of the things I think about is, particularly in the realm of engineering, one of the things I see happening all the time is I sometimes think of the process of innovating or engineering as being a little bit like the old game of Battleship. Do you guys remember this game of Battleship? A handful? It's where you guess what's going on the other person's board. And so I would say something like D2, and the person goes, miss. And then you go J3, miss. And I think a lot of engineering has that iteration that goes back and forth, where we take something, we test it, it doesn't work, back to the drawing board, do it again and again. And I think we beat into people's heads that that's a good idea. I'm totally unconvinced that it's a good idea to do that over and over again. And while iteration certainly leads to some better answers, one of the things that we now have available with infinite computing is the access to model and analyze and simulate these things before we ever build anything. And for anyone who's ever built anything, if you knew at the beginning what you know at the end, you would do something differently. And so I say what we really need to do is really examine our mindset that says that computing is scarce and precious. And I think we have to re-examine our tool set and say, what will it take to look at these problems differently? And how can we do something differently as a result of the insights we gain? And so, for example, if I think that I have all the computing power in the world, as much as I wanted, the idea of trying one design at a time seems silly. Why don't I test 1,000 or 10,000 or 1,000,000? Why don't I instead ask the computer, find me the optimal answer to this, instead of asking one at a time in some serial fashion? So I think this infinite computing is incredibly important. Now what I wanted to do is, and I wanted to leave some time to have everybody ask questions, because that's where you guys pay me back, because I learn as much from what you guys have to say, and I want to hear your questions and your thoughts. I wanted to end talking about 3 companies, and it's interesting, all 3 companies here that I'm going to talk about are in the Bay Area. And I just happened to visit all 3 of them last month, and I think this is just a great example of entrepreneurship and what's really possible if you set out to do what is the seemingly impossible. So the first company is a company called Moon Express. Moon Express is headquartered down at the NASA Ames, down in Mountain View. Started by a handful of young folks, and they worked in conjunction with NASA when NASA reached out to crowdsource a lunar lander. Right now they're planning their own mission to the moon, a robotic mission to the moon. And what's really interesting about what they're doing is they're rethinking how to go to the moon. They're doing it with a handful of people. There's probably 30 people in the company. 20 are under the age of 30, and the other 10 are grizzled veterans of many NASA missions. And they're rethinking everything. Like I was in there the other day and they were showing me the avionics system. And they said this avionics system weighs 1/6 of what went up in the last mission. So they're really just questioning all the assumptions, going back, breaking the rules, and saying we can do this differently. And their design is different, and they're thinking about the problem differently.
Is somebody paying them to go to the, I mean, how?
So how are they paying? So they've raised venture money, and I'll talk about that in a little bit. They raised some venture money, and they're competing for the Google X Prize. But the Google X Prize doesn't pay unless you win. So, I mean, they're just competing along with, a dozen other teams. Here's a second company down in San Carlos. It's called Lightning Motorcycles. So Lightning Motorcycles just broke the land speed record for electric motorcycles. They went 218 miles an hour on a motorcycle. By the way, okay, engineering question. What's the hardest problem about going 218 miles an hour? Okay, we got stopping, we got turning. It's keeping the rider on the bike. It turns out to be the hardest thing that they ran into, is that at 218, the rider just wants to blow off the back, which would make it hard to stop and turn and everything else. But that was the first. It wasn't keeping the bike on the ground. It was literally just keeping the rider on there. Actually, the rebuilt motor for my son's go-kart came from these guys. He wanted the 40 horsepower version. I thought 20 was more than enough for the go-kart. Anyhow, again, handful of people. They broke the land speed record for a production motorcycle. There's also, every year, there's a race of gas and now electric bikes up and down Pikes Peak, and they just blew away the gas bikes on that race. Okay, third company. This company is incredibly cool. It's Cambrian Genomics. Cambrian Genomics is a small company. It's south of Market in San Francisco. It's got about 10 employees, and what they're doing is 3D printing DNA. Sounds incredible, right? So you go in there. First time I walked in there, there was a box there. It looked like a 3D printer that would do melted plastic, and there were a handful of tubes coming in, and the guy who's had the idea and is the CEO of the company started explaining to me what they're doing. I'm like, slow down, I'm not that smart. Tell me what you're doing, because I'm just trying to figure out how do you 3D print DNA. And so he said, and he starts talking, I said, okay, let me ask a couple questions. What are those tubes coming into here? And he goes, A, T, C, and G. And so what they've done is figure out how to print DNA. They get about a 30% yield. They figured out how to select the good from the bad, so that and the materials are relatively inexpensive, so a 30% yield is good enough. They put the short strands together to make long strands, they resequence it, and they're producing long strands of DNA. They think that this year they will be able to produce more DNA in a single run than it is possible to create in the rest of the world. That all the other techniques right now, this one small company is going to be able to create more DNA in a single batch than is created in the world today in a year. So kind of incredible. Three things that these are almost, startups coming out of garages. So the interesting thing about these companies is between them, they don't have 100 employees. Between them, they didn't even raise $10 million in venture capital. Now, there are some characteristics that I think are incredibly important about these. Number one is when you look at the teams that they've put together, there's just this wide array, just this diversity of experience and knowledge. So for example, what I think is really interesting at Cambrian is there's one mechanical engineer, one geneticist, one expert in microfluidics, one person who's expert in optics. Now it was interesting when I went there. I went there the first time with a former professor of mine, and he walked in and he heard the whole story with me, and we were both blown away. And we walk out. I said, "What do you think?" And his first thing he said to me, "This would never happen in the university. This will never happen in academia, because for all the talk of people working together across disciplines, it doesn't happen in this way." So what was interesting about Cambrian is there are no two people in that company who have the same expertise. They just assembled the people that they thought were the best at each one of these things. The other thing is when you look at something like Moon Express, that combination of people who, right out of school, new ideas, enthusiastic, almost don't know what they don't know, combined with some of the serious veterans who have lots of experience and maybe a few too many battle scars, and putting those two together to say, we're going to keep challenging each other about what we can and can't do. So I think what they've done is kind of incredible. And this is just 3 companies that I've seen. You guys probably know about lots more. There are dozens out there. And, I was thinking about it, and there's this quote that I really love, and here it is. It's by Henry Ford, and it's whether you think you can or whether you think you can't, you're right. And I think there's a lot of truth in that. I mean, I think if any of these people started out with the idea that it's impossible to build an electric motorcycle like that, or that a handful of us are going to build something that flies to the moon, or that we're going to 3D print DNA, I think you'd start out with the idea that this is impossible. But I think it's because they had a belief that they could do it. They've actually been able to achieve it. And I think all of these three companies, they've all either succeeded or are on the road to success. And I think that's what's so incredible. So, in the spirit of career advice, what I would say is, I can't really think of better advice than that. In setting out in something that you care about and something you're passionate about, and that may seem impossible to the others, but hard work and dedication and some insight, and you can find yourself on the moon. So let me see if there are any questions. Like I said, this is the time where I get to do the learning. Just curious, happy to answer anything you want about any of these companies. I know there was some interest in 3D printing. I'm more than happy to talk about 3D printing. Whatever's on your minds. Oh, there's someone who's not as shy as the rest.
So for Cambrian, that company, the DNA company, what are their plans to do with the DNA after they copy?
Yeah, so it turns out that it's a great question. It turns out that there's a lot of people doing interesting stuff with DNA. And there's really two things that are going on with DNA. One is people are actually doing science with it. People are making it and they're trying to build biological things with DNA. So the other is there are a bunch of people who are using DNA as a structural component. And so one of the really interesting ones is there's a group at Harvard University at the Wyss Institute that's actually building nanoscale robots out of DNA. And what they rely on is this property of, remember the base pairs and how they go together, and that you get this self-assembly. So that if you order the right strands, and you get online and you go to CambridgeGenomics.com, you order your strands, show up, put them in a beaker, mix them up. DNA will only assemble in known configurations, known topologies. And so this group at Harvard is building nanoscale robots. First experiments they did is they just tried to build little things, different shapes, smiley faces, write your name with DNA. And it's great. The early work on this, you see the DNA and then you see the electron microscope picture of it, and it's actually that. And so what these guys are doing is building a nanoscale robot that when it goes into the body and it attaches to a particular cell, it opens up and delivers a payload of drugs. And so the idea, of course, the immediate thing that comes to mind is something like, treating cancer or things like that. And I think, ideas like that are really interesting, and it'll make some of the things like the way we use chemotherapy today seem barbaric. When we look back on this idea that you poison the body in the hopes that you hit the right cells is going to seem incredibly crude. When we look back and say, so you really drilled holes in people's heads when they had headaches. I think that's what people are going to say about us in chemotherapy. So I think there's both some of the structural stuff going on with DNA and there's some fascinating work going on biologically with DNA.
So how do you see a company like Autodesk reacting to these kind of teams that are super specialized and don't know what they don't know and have too many battle scars? How do you see companies like Autodesk that try to facilitate these processes coming to the table to be part of that team? Where do you fit in that role?
Yeah, so we see ourselves as tool makers. We build tools to help people. Now, the interesting thing in your question, it's way easier that if you look at an industrial giant, how do you engage with them? It's easy. We build these tools over a period of years and we give them to you. And It's a reliable, steady relationship. There's not much perturbation in it. I think working with companies like this is the most interesting. And so one of the things that I try to do, as the CEO of Autodesk, is reach out and try to find the companies that are doing the most interesting stuff, knowing full well that some of it's going to fail. But I love trying to build tools, for these boundary cases. The idea being, if you do it well for the people who are reaching to the extremes, that over time, the thing that seems like it's at the edge will become mainstream. So as an example, I showed an image before of like the movie Avatar. One of the things that was interesting about the movie Avatar is that all the animated characters were not animated by people. They're not animated by the sense of people who were artists and drew them. The entire film was motion captured. And so we built the software that Jim Cameron used that allowed them to do that. And when we did it, it wasn't clear that they were going to succeed at this, but we said if they do succeed, future animated movies will be done that same way. That's where we look, and we try to say, what's going on that's interesting? So right now we're doing some work in, for example, designing things at this biological scale. So one of the things that we saw with the work going on at Harvard, as they were trying to design what strands of DNA. So here's the problem. I want something that looks like this. What strands of DNA do I put into the beaker to make those? Well, when we first encountered them, they were using, the world's oldest source of labor, graduate students, to figure this out. And so they had graduate students with, like yellow pads of paper trying to figure this out, and it was taking months to do it. And we said, this is a perfect problem for a computer. And so we try to go look and, so what we're doing there is saying, what can we take from the lessons that we know about how people design things in the inert world and do that in the biological world? And if we're successful, we think over the next 10 or 20 years, you'll see lots more things being built and assembled biologically. So everywhere we go, we're always trying to find the people who are doing the most interesting, most cutting edge, most kind of out there stuff, with the idea that that's where you get your biggest inspiration. So.
Thanks. Do you think you could give us like a day in the life of, being a CEO of a company? A big company.
Day in the life of the CEO of a big company. Yeah. So I can tell you today. So today I did 2 early morning phone calls. Then I did 4 product reviews. Like hour-long product reviews. Spend a lot of times these days in telepresence, video conferencing. And then I went to lunch with a venture capital guy, who's kind of a friend, just to hear what's going on. Came over and met with the dean of the engineering school, and now I'm here. I think one of the things is, I think the more important and kind of serious part of it is, in any given day, I have 10 times more stuff to do than any person could do. And so the trick is figuring out which stuff you do. It was interesting. I was just in Europe and I went to and we have, 100 offices around the world. And I went to the Switzerland office and I hadn't been there in a couple of years. And after I was done, they said, oh, it was great. It was so nice you visited. So you'll be back next year. And I thought to myself, if I just spent all the time visiting the offices, that would fill all of my time. If I just reviewed all the products, if I met with all the investors or all the press or all the anything. And so I think the hardest part of having executive jobs at, larger companies is figuring out what's really important. And people do, and I think it's important to figure out what's the difference between the truly important and what's urgent. And you get a lot of people with urgent stuff. Like when I'm just standing at my desk, people are coming up, you got to sign this, you got to do this, you got to do this. And if you let it happen, you get consumed with the urgent and you never do anything important. And I think it's, you really need to step back. Now, one of the things is I've done this job for a while now, and I've definitely been able to be better at figuring out the things I have to do and the things I want to do and what I think is important to do than certainly at the beginning. In the beginning, I was probably a little bit like a piñata. Like go over here, and someone whacks you over there and you get whacked again, you just go running around doing all this crazy stuff that people think is important, and in the end, I don't think it's important. Now, the other thing I've come to the conclusion, and I'm not sure this is quite true, but I'm working out this hypothesis that says, I think most executives think that many of the day-to-day decisions they make, they put way too much weight on it and think they're way too important. I think in truth is, there are two things that you really do as, let's say, a CEO of a bigger company. One is I think you have a fair amount of influence over the culture at the company. And the culture is, really broad in terms of who you hire, what do you value, who gets rewarded, what do you prioritize, which constituency, your customers, your employees, your shareholders. So there are things about the culture that you can set, and organizations tend to adapt to that, and they figure out what the leaders of a company want. The second thing is, I think they probably, if you look back on anybody's career, you'd probably say there's 2 or 3 or 4 or 5 decisions that really made a difference, that had an impact, either for good or bad. It was interesting, and I'm glad I didn't mention names. Like I was talking to this venture capitalist at lunch, and one of the things I said to him is, so what is the stupidest investment you didn't make, which was the biggest mistake? And so they said they had a chance to invest in Pinterest, and they couldn't figure out how it would ever be a successful company. And I said, was this a passing thing? He said, oh no, we had 4 or 5 meetings with them, and we still couldn't figure out how this was going to be successful, and they didn't have some of the basic ingredients necessary. And so I think, recently, for example, Steve Ballmer, announced his retirement from Microsoft. And if you look back he may have been CEO 15 years now. I mean, it's been a long time. If you look back on the time he's been CEO, probably you'd say every day he made dozens of decisions. There were probably only a handful that mattered. Did they move quickly enough into mobile devices? Did they do enough with tablets? I mean, some of these answers are obviously, self-evident. Was the Zune a good idea? By the way, I never got more scorn. I went to this thing at Microsoft, and I brought home 2 Zunes for my kids, and they were probably 10 and 12. And they just looked at them, and partially because they're spoiled rotten, and partially because they have good instincts, they looked at it and said, don't give them this. These are the most useless things I can. Who would want one of these things? And so you sometimes wonder, how do companies, go on this kind of road to nowhere when, some of the things are so obvious? I mean, it took a 10 and 12-year-old son to say this was ridiculous, and they were still investing millions of dollars in it. And then some things are, I think at the time are a little bit less knowable. I ride BART to work. I work in San Francisco, and there's more money being spent on ads for the Microsoft Surface than can be believed. Every train is just covered with those things. I got off, and I said to my friend that we were riding the train, I said, do you think it'll be successful? He said, were you looking at all those ads? I said, yeah, I was looking at all those ads. And I think something like that's a little bit still, out there. Okay, let's do an experiment. How many of you have a Microsoft Surface? The one proud owner way in the back. Okay, I think I know the answer to the question about whether the ads are working. It's kind of interesting, but back to the question of what do you do? I think if you have this view that says you can affect the culture and you can affect a handful of important decisions, either decisions you actively make or things you miss and somehow have avoided, and you focus your time around centering on those activities, I think you do better than this idea of this nonstop to-do list, because the to-do list is way too long for anybody to do.
Earlier in the presentation, you mentioned about your new fabrication facility. Can you tell us about how that fits in with the rest of the company?
Yeah, sure. So we just built this thing down on Pier 9. Pier 9 on the wharf in San Francisco. It's right next to the new Exploratorium. And it's about a 35,000 square foot facility. Half of it's kind of desks and office space, and the other half is a digital fab workshop. And the reason that we built it, it houses a couple things going on there. Well, let me back up a little. The idea is, I think for many years, we've spent a lot of time as building design software, helping people kind of build digital prototypes on this side of the screen. Behind the glass, we help people, lay out a car, test what it would crash like, finite elements, computational fluid dynamics. But I think, as I talked about in the beginning, what's exciting about what our customers do is they really want to go from an idea to a finished product. And I think we've stopped too early in the process. And so we've gotten really interested in what software is involved in going all the way from when you have a CAD model all the way to you have a finished product in your hand. And we've gotten really interested in that question of being able to complete it and understand it. And in some ways, starting to build things that, are instrumented and censored in a way that you can understand how the thing's used and have that feedback into the design cycle. So that was the inspiration for this. What we've done as a result is, I don't know, any of you know the Instructables website? So Instructables is a website where people go and they publish things about how to make stuff. And it's making everything from like cupcakes to thermonuclear devices in your backyard. Okay, my favorite Instructable of all time was this guy. He made a little video, and what you see him is in like a basement or a garage, and he's laying out like lightweight conduit, like electrical conduit, and he's just bending this stuff. And then next thing you see is something like a fishnet being put on top of it, and then you see this big propeller, and then you see like a climbing harness, and he's strapping it together, and you're like, what is this guy doing? And next shot, he's about 1,000 feet up in the air, and he has this, kind of paraglider. So what he had was a small, internal combustion engine with a parachute, and he launched himself, and he's coasting over these hills. And you think about like people get all worried about people like 3D printing guns. I think the things you could do with stuff available in the hardware store is way crazier than 3D printing a gun. Anyhow, that's my favorite Instructable of all time, but there's lots of Instructables, and so the Instructables team all works there and they test out ideas. We have a bunch of free software called 123D Stuff. All the 123D guys, the software developers and designers are down there, because the idea behind all of that is not just to model something, but it's to build it. And then recently, we've gotten really involved with CAM software, computer-aided manufacturing or machining. And so we have all these really high-end CNC machines in which we can test out, whether we can go from CAD model all the way to finished part. By the way, I'll put in my pitch. We had a lot of interns last summer from Cal. There's actually an artist-in-residence program there. As well, so people who want to spend time at the shop and have access to it. I think last year we had, in the Bay Area, we had 160 interns during the summer, and a whole lot of people from Cal. So as summertime comes around, if you guys get interested, and that's the jobs I would look for, the ones at Pier 9. Yeah. Okay.
Hi. Thank you for sharing your experience with us. I would like to ask you, what are some of your thought processes when you first started your own company? Like, what are the thought about whether is it a calculated risk? How do you know if an idea is worth pursuing? Because I suppose that most of the time an idea always seems good to you, but in reality it is not. So how would you know?
It's a great question. I wish I had a really good answer. Here's one of the things I would say is, I think one of the things about these ideas, I think if the ideas are lacking passion and interest, they're bad ideas. People who say, I want to just start a company for the sake of starting a company. Or I met someone the other day, they were working at a consulting firm, and I said, so what are you going to do in your career? And the person said, I want to be a CEO. And I said, CEO of what? And they said, CEO of, I don't care, I just want to be CEO. And I thought, wow, that's a weird answer for me. Because I'm really from the other side, which is fill it with content. What do you want to do? And so I think one of the things that's really important with the ideas is, are you making something that you want to have come into the world? Is this thing important? Are you trying to solve a problem? What are you doing and why do you care about it? I think that's the first indication, because if you don't care, I think it's very little chance that other people care. Now, I talked about some of the things that I think are now out there. I love this idea of things like, Kickstarter, where you can really quickly go from, is this just my good idea and I'm in love with my own good idea, to, I can put it up there and ask people to pay money to support this idea. So I think there are now ways that we can test out the ideas. Now, the interesting thing to me is people are willing to put their ideas out there, even with the chance that they might get stolen. So it's a really interesting kind of duality between having to share with the community and still being at risk. But I think there's lots of access. But what I go back to is make sure you're building something important, make sure it's something that you care about, make sure it's something that'll make a difference in the world, and then you're probably on to a good start. So let me just close up by saying thanks. I'm willing to stay around. If anyone has any questions, I'll be down here. Happy to talk to anyone else, but probably the rest of you have schoolwork. Go do your homework and all the rest. Thanks.
Just announcement, the box to drop the feedback forms is just outside when you go.
So I just wanted to remind everybody also, we'll have the survey tonight. And also there's a report due. And next semester, if anybody is interested in attending some of the Newton Series lectures, let me know, because we'll have extra room. And if it's a speaker that you're interested in and as vibrant as Mr. Bass, then maybe you want to attend it even if you're not part of the series.
Okay, thank you.